Hello everyone, in this video we are going to be doing a comparison between Amazon Aurora and DynamoDB. These are two of probably the most popular database solutions that exist on AWS today, and I think a lot of people really get hung up on the details when trying to decide between one or the other for a new project. So what we're going to do in this video is I'm going to do a brief overview of Amazon Aurora and DynamoDB, describing what they are, what the structure is, how they scale, and kind of how the technology works. From there, we're going to move on to an example scenario where we model our application using RDS Aurora and then in comparison using DynamoDB. And this will help you really understand how the mental model shifts when you're using one or the other. And then finally, we're going to have a section that's dedicated to helping you decide between one or the other. So that's what the agenda is for this video. So let's jump right into it. All right, everyone. So first of all, what I wanted to do is just a brief comparison between RDS and Aurora, because these are two things that belong to the same section of the AWS console, and a lot of people get very confused in terms of what the difference is between one or the other. We're going to be focusing on Aurora for most of this presentation, but let's just quickly go through what the difference is between these two technologies. We have RDS and Aurora here, so let's start with the top by going through what RDS is. So RDS stands for Relational Database Service. It's a very old service that was launched in 2009 by AWS, and essentially it's a managed database solution. So what that means in practical terms is that it intends to simplify using databases by handling hardware provisioning, setup, backups, patching, storage auto-scaling, and more. So really the intention of RDS is to simplify all the nitty-gritty, all the stuff that you don't really want to have to manually do if you're going to go and set up your own database instance on something like EC2, for example. So really it just allows you to spend more time focusing on your business problem as opposed to worrying about operational and maintenance tasks for a database instance. So RDS itself offers many database engines, including MySQL, Postgres, SQL Server, Oracle, and MariaDB. Keep in mind there's different pricing for each of these different types, and if you're using something like SQL Server or Oracle, you do require licenses that you need to purchase from the specific vendor. So I would say, like in a nutshell, RDS is very, very similar to running a MySQL database on EC2, but a lot of the stuff that you would need to do if you actually set up on EC2 is handled for you. So things like deploying to subnets, things like security groups, things like patching, auto-scaling, incremental version upgrades, all of that stuff is made much easier for you. So RDS is a great choice. There's no reason that you should be doing something like MySQL on EC2 and rolling that your own when you have a product like RDS that exists out there. So that's what RDS is. Let's compare that with Amazon Aurora. So Amazon Aurora is a database engine that is optimized for the cloud. It is an engine that was launched in October of 2014, and it's proven to be a very popular option that provides a lot more value add services when compared with something like RDS. Now keep in mind that Aurora is a specific database engine. It's its own underlying database implementation. So it's not Postgres, not MySQL, not MariaDB or anything like that. It is its own thing. However, to make it more attractive as an option to people that are more familiar with using other database technologies, it is compatible with both MySQL and Postgres. And this is something that you define when you're creating your instance, just a very simple option that you tick. Do you want to use MySQL compatibility or Postgres compatibility? Now, what makes Aurora extremely special is that it uses an innovative shared storage architecture, which decouples storage from compute. So in a traditional database setup, you'd have a machine and then have a hard disk associated with it, and your storage and your compute are the same machine. But when working with Aurora, they allow you to decouple those two things, and that allows you to achieve much higher performance throughput. Now, Aurora does offer some features on top of those in RDS, and that includes things like over 5 times the performance that you would see on a normal MySQL database instance. Keep in mind, this is the metric that they publish as kind of a selling point. I don't expect everyone to get 5x performance during normal usage, so just keep that in mind. You may want to kind of experiment with it on your own. You get access to more read replicas with a very interesting feature called read replica auto scaling. If you're using something like Postgres on RDS, you get access to 5 read replicas, which you need to set up on your own. And I don't believe those offer auto scaling in any form. Now that decoupled storage and compute technology means you have higher availability. So behind the scenes, Aurora is actually replicating your data into different availability zones so that if your primary database goes down at any point in time, you're going to have replicas in a sense that are available in other availability zones that can quickly become the primary. So very, very handy feature. It's got higher availability compared to RDS. And you get automatic backups with no performance impact, which is a huge boost. And then finally, as of a few years ago, you also have access to a serverless option, which is kind of what Lambda did for EC2. That's what Aurora is doing for databases. So not having to worry about servers is definitely a plus. There's a whole kind of laundry list of pros and cons with using the serverless approach, but we're not going to really kind of be talking about that too much in this video. This is using a more traditional comparison between provisioned RDS Aurora and DynamoDB. So that's what RDS is, that's what Aurora is, that's kind of the lay of the land in terms of the difference between the two. So I just wanted to give you one more slide just to clarify the difference in a kind of a simple formula, because some people still get confused here. I know this took me a little bit of time to really grasp the difference between these two. So at the top we have RDS here, and when you're setting up your RDS database, you have the option of using all these great engines, so MySQL, Postgres, SQL Server, Maria, or Oracle. And then you also have the option to use Aurora. Now, if you select Aurora, you need to select whether or not you want to use MySQL or Postgres. And then, of course, they do have a serverless option that works with either Postgres compatibility or MySQL compatibility. So again, that's just kind of the difference between these two, and just kind of a quick and easy flow chart just to demonstrate this point. So that covers what RDS Aurora is. So let's move on now to talk about what DynamoDB is. So what is DynamoDB? Now, DynamoDB is a NoSQL database engine. It's an extremely popular database. I would say even more popular than something like MongoDB these days. You see a lot of customers for DynamoDB that require very high throughput with consistent performance, and that's really what DynamoDB provides. Now, it is NoSQL, which means that it's optimized for key value lookups. That does mean that it's not intended for things that RDS is a little bit better for, things like aggregations and grouping. That's not something that DynamoDB is well suited for. In fact, that's not something you can even do at the database level. You'd have to kind of pull your data out of the database and then do grouping on your application layer to achieve a similar functionality. So it's definitely a different way of using your data, and it requires a shift of mental model, which we're going to get to in a couple of slides here. So in terms of why you would want to use it, well, it's great for very high performance workloads with very predictable performance. In my personal experience, I've had applications with over 3,000 transactions per second hitting this database with no impact to performance. I can't say the same for what that would look like with an RDS. I haven't tried it personally, but just keep in mind, like, this is the benefit of using DynamoDB. You get very predictable performance at very high throughputs. Now, on top of all that, DynamoDB is a fully managed database solution. So all you really do is you go into the console, you create your database, set some limits, and you're off to the races. It can scale elastically to very large databases, think like terabytes of size. Also supports things like global tables, automatic backups, auto scaling. There's a whole laundry list of different benefits that come with using DynamoDB. Now, what's neat about DynamoDB is that it operates on a pay for what you use model. In fact, there are a whole bunch of different kind of pricing models that you can use when you're operating with DynamoDB. The first one is kind of, it's more meant for bursty workloads. So you just kind of say, DynamoDB, I want you to worry about scaling. I want you to worry about everything. And you just pay for essentially what you use. The other options are more of a provision model where you can associate auto scaling rules. So as your request rate increases on your DynamoDB database, it'll automatically scale it up so that it'll be ready to receive all of that traffic and not have anything like throttles or degraded performance. So it's definitely flexible depending on how you are using the engine. And finally, I wanted to also mention that DynamoDB now supports transactions. So transaction is kind of a all or nothing, all succeed or all fail kind of operation. And typically transactions can happen across multiple tables at once. This was a very common complaint against DynamoDB and why people tended to choose something like RDS or something like Aurora over a NoSQL solution like Dynamo because it didn't support transactions. Now it does. So there are some limitations that you need to be aware of in terms of how many items you can update at once as part of a transaction, but you do have access to those ACID principles. So atomicity, consistency, idempotency, and durability through transactions. Now there's one additional point here that I wanted to touch on, and I didn't really have a point here for it, but it's the fact that when you're using DynamoDB, you also have access to all these great other AWS integrations applications. So you can do things like set up DynamoDB streams so that on record level updates, you can get kind of notifications where you can compare the before and after value. That's called DynamoDB streams. I have a whole video on that. There's a whole bunch of other integrations with Lambda functions that you can do, integrations with API Gateway. I have a whole bunch of videos on all this stuff, but what I'm trying to tell you is that you get a whole lot of value add by using DynamoDB because it integrates really well with other AWS services that exist in that ecosystem. So don't kind of forget that point when you're trying to decide between one or the other. There's a whole bunch of value added features that come with DynamoDB. Now, next I wanted to kind of get into more of the details of the differences between them. And I like to think of this in terms of 4 quadrants of database technology. So the first quadrant that I want to talk about is structure. So how is the database organized? Are we talking about graphs? Are we talking about tables? Are we talking about documents? A lot of different databases use different structures, and I want to kind of touch on the difference between Aurora and DynamoDB. The second is in terms of storage. So how is data actually stored in the underlying system? That's important to understand limitations in terms of scalability and how your application will behave when the size of your data grows to very high levels. Next, I wanted to talk about scale. So how does your application actually scale out when it requires both higher throughput and higher storage? And finally, how do you actually access the thing? How do you kind of perform queries? Do you do it through a database connection? Do you do it through an API? Do you do it through a neat UI that kind of shows you all the information in a nice, clean, and organized way? So how do you use it in real life? So these are the 4 areas that I want to talk about. So let's first start out with Amazon Aurora. Okay, so moving to Aurora here. So we have our 4 quadrants: structure, storage, scale, and access. So let's start with structure. So in terms of structure, there's no really surprises here. This is just kind of how you organize data in a traditional SQL way. So you have tables. Tables have primary keys. They also have foreign keys that you can link to other tables through what are called relationships. And let me just kind of highlight that for you here. So if we have an accounts table and a country table here, if we have a foreign key on country ID, we can very easily build a relationship between the country table. So we can answer questions like, what are all the different accounts that are originated in the country of country ID 1, which is USA. So you can build relationships between your tables here so you can very easily answer those style of questions. Now you also use schemas, and schemas allow you to define things like configurations of your database, so what your structures are going to look like. Also allows you to define things like constraints on your different column types. So for example, if we look at the account ID column here, it's a variable character, or varchar for short. We look at creation date, it's enforced as a date type. And if we look at country ID, it is an integer type. So by using Aurora, you have access to all the tools in your toolkit in the form of tables, relationships, and schemas, very typical of what you would see in just a normal database based on a SQL engine. Now moving on to storage, and at first I want to talk about the innovative nature of Aurora because it does something a little bit special, and it decouples your compute and your storage tier. Now, this is what allows Aurora to achieve its very high throughput and a lot of the different benefits that are offered, as opposed to kind of partitioning your data or having just copies of an entire database instance on independent machines, including storage. You have a distributed storage system that exists on its own. So traditionally, these two things used to be together, both the compute and the storage, but now these two things are separated in this Aurora configuration. So there's also some other kind of notes to make here in terms of functionality, and it does offer multi-AZ replication. So what that means is that when an item is written to your database, it'll asynchronously replicate that to different availability zones. So for instance, when a write occurs, it may go to this top one here. The top one may be in availability zone US East 1, and the primary may be in US East 1B, and then it'll also replicate it to a second availability zone. This one could be in US East 1C. And the main benefit of this is that if 1B, or the one in the center here, fails for any reason, you can very seamlessly, with no downtime, no interruption, fail over to a different node that's in a different availability zone. So this is how Aurora achieves higher availability when compared with something like RDS MySQL or RDS using SQL Server or something like that. So it's a great thing if you're looking for more resiliency and more availability for your database engine. And because of this kind of distributed storage system, you have access to much higher limits in terms of how large your database can be. For Aurora, you have access to 128 terabytes maximum size, which is a ginormous size in itself. If you're using something like just RDS, the sizes are dependent on the engine that you use. So I believe MySQL offers something like 64 terabytes, and I think it's different for Oracle and MySQL Server. Again, it's engine specific, so you'll have to check into that. So that's how storage works with Aurora. Let's move on to talk about scale now. So how do we actually achieve higher throughput when we're using Aurora? So generally there's two ways to scale for higher throughput. The first way is through vertical scaling, and that basically means you just upgrade your machine. That's just a click away in the Aurora console. You just say, I want a new compute node and I want it to be, I don't know, an R6 2XL instance, and no failovers, no kind of downtime or anything like that. You'll get an extra machine that is with that configuration. Now, the other way, which is probably the more common way to achieve very high levels of throughput, is through what is called horizontal scaling. And that just implies that you add more machines and split up the work amongst all those different machines. So that's kind of the more popular one, and let's dig into that a little bit. By the way, if you're confused about this topic, I have a whole other video on horizontal scaling, which I'll add in the description section of this video. So in terms of how horizontal scaling works specific to Aurora, you have what's called a master node. A master node is responsible for all write events. So anytime someone wants to write or add data or modify data or delete data in your database, it needs to do so through the master. So say for instance, my database is growing, my customers are growing, I need more throughput on this application. I need to be able to handle more reads. So how would I do that? Well, Aurora offers read replicas. So you can very quickly launch multiple different read replicas. So let's say we're going to add reader 1 and reader 2 here. Now you don't even need to worry about doing this manually. You can actually set up auto scaling so that if a database metric gets past a certain point, could be something like throughput or I don't know, another form of utilization, it can automatically scale up the number of reader nodes to up to 15 reader nodes. So you can alleviate traffic on your master, so only dedicate writes to your master node and direct all your read traffic to the reader nodes. So again, that can go up to 15 reader nodes, which is extremely impressive. So digging into this a little bit more, when you set this up, you get assigned a cluster endpoint, which points to your master node. So all your write traffic should be directed towards there. And this is literally like a connection string that you can interact with. And then also you get a reader endpoint. Now, if you have a whole bunch of different readers, you obviously don't want to keep up to 15 different reader endpoints. So Aurora offers a very convenient functionality where you get one endpoint for your reader, and that is responsible for directing traffic to any of the actual reader nodes. So it's kind of like a load balancer that sits between you and your reader nodes. So you don't need to worry about like, what reader node am I going to communicate with if I want to perform a read operation? You just hit that one reader endpoint and it'll distribute traffic to whoever is best suited for that job at the time. So really cool stuff by Aurora. Really simplifies a lot of the scaling, complexity, and management to make your life a whole lot easier for building these really high throughput applications. So let's move on to access now. So how do we actually talk to the database? How do we communicate with it? So the first way is through just a traditional database connection and writing your raw SQL. This is very popular. A lot of people have done this for many years. And if you're comfortable writing raw SQL and forming that database connection, all the power to you. Keep on doing what you're doing. Now, for those of you that are like me, that are a little bit lazy and don't want to write like low-level SQL to do what I want, you'll probably use something called an object relational mapper. Sometimes you'll hear that called as an ORM for short. And essentially what this thing does is that it is an object that you kind of interact with in your programming language to say like, perform a query that gets me all the records with this type or does groupings. And essentially, it's a way for you to access your database in a much more convenient way without worrying about raw SQL. There's many different ORMs that are typically tailored to the language that you're using. So a very popular one that I've used a lot in Java is one that's called Hibernate, and that just makes your life a whole lot easier. Now, I wanted to touch on a new development in Aurora in terms of how people actually access it and work with it, and that is what is called the Data API. And the Data API is a new development. This just came out pretty recently, and I really think this is going to change the way that people interact with databases because it is a great simplification in terms of how to do so. So let me explain to you how it is different than the two options above it. So the Data API allows you to write and submit queries using a REST endpoint. So instead of forming a database connection in these above two options, all you have to do is write up your SQL statement, feed it to an SDK, which creates a REST request to an endpoint in Aurora, and Aurora will run that SQL query against your database. Internally, it's managing that connection pool and doing whatever it needs to do to talk to your Aurora instance. But from your perspective, from the user perspective, you are just creating and firing off REST requests. And this greatly simplifies using something like Aurora because you don't need to form connections. You don't need to worry about rounding out your database if you have too many clients and too many connections. The Data API is extremely convenient. I already love it. I tried it for a new project. I'm going to continue using it. I really do think that this new way of talking to databases is going to be kind of the de facto option of choice going forward. So if you're not already familiar with it, I highly suggest you go and check it out. So this was a brief introduction to Aurora talking about structure, storage, scale, and access. Let's do the same comparison now, but for DynamoDB. So Dynamo, and let's get those 4 quadrants up here again. Perfect. So in DynamoDB, in terms of structure, you still have access to things called tables, and tables are just collections of items, and items are the kind of rows in your database or the entities that exist in your database. Now, you don't have your traditional primary key in the form of a single column, although that is possible, but let's just kind of run through here the general format of the structure. So this is a table, this entire kind of structure here, and then these are items. So item 1, 2, 3, and 4 that are in this table. Now the primary key consists of 2 items, a partition key, and the partition key is essentially responsible for segregating your data onto different logical partitions that exist in the DynamoDB engine. And then you also have the choice of defining a sort key, and the sort key allows you to do things like get me all the items within range of, in this case, within a specific date. Very, very convenient in terms of enhancing your access patterns. Now, if you want to look up independent items on a secondary field by ID, for example, you can create what's called a GSI, which stands for Global Secondary Indexes, and that allows you to do constant time lookups. For example, if you're looking for what are all the accounts, so these are different accounts that are belonging to the country USA. So you would use a GSI to make that a constant time lookup. And then over here, you just have attributes. And the neat thing about DynamoDB is that it is effectively schemaless. Besides the partition key and the sort key in your GSI, you can basically dump anything into the attributes. So some very complex data objects that have their own fields and types, you could just dump that into a raw attribute field for whatever you're using it for. So pretty handy, pretty useful. Keep in mind if you're dumping JSON data in here, keep in mind that you're not going to be able to index it using a GSI effectively. So one of the limitations there to be aware of. Now, in terms of storage, how does storage work in a DynamoDB engine? Well, it all relies on something that's called a hashing function. And a hashing function is basically a function that's written by Dynamo that helps Dynamo decide which partition your data is going to be located on. So let's run through a very quick example here. So it all starts with your function, f of x in this case, where x is the input that you're going to provide your database. So let's say we want to add item 1 to our database instance. You'll pass item 1 and its payload, maybe it has a couple attributes, into DynamoDB. DynamoDB will take item 1 and it'll hash that into a unique value, and that value will effectively point to a particular partition that exists within DynamoDB. Now, this partition can be its own independent database that exists in isolation of other partitions. So the output of the hashing function is the location or what partition this record will be located on. So the output in this case was partition 1, and now item 1 exists on partition 1. And so let's do this for a second example. Say we have item 2, the same operation is performed, f of x, and maybe the output of this hashing function is partition 2. And again, this can be its own independent instance on whatever storage storage engine they're using behind the scenes, but it exists in independence of partition 1. Partition 1 and partition 2 have no idea that each other exist. And just running through the example here, we decide that it goes on partition 2, and now item 2 and its payload exist on partition 2. So now DynamoDB knows exactly where these items with these particular keys are located. So let's do the reverse now and assume that you're looking for an item. Let's say we're looking for item number 1. DynamoDB will hash item 1, see what the output is, and that output will point to partition 1, and that's where our item is located. So DynamoDB will know exactly which partition that item is located on and where that item is on that partition. So that's how it achieves some very impressive lookup speed that is consistent, especially as your data grows. So that's kind of how data is stored within DynamoDB. Let's talk about scale now and how it achieves some very awesome, essentially infinite scale. So in terms of scaling, there's a very simple formula here, and it's not that complicated. So the way that DynamoDB scales is either adding more or splitting partitions. So in the above example, we only had 2 partitions, but there's nothing stopping you from having this hashing function have a whole bunch of different partitions. Partition 1, partition 2, partition 3, partition 100. Essentially, your data can just keep on horizontally scaling, and since each of these partitions are operating independently of one another and don't know anything about each other, you can just keep on adding more and even breaking apart partitions if your data on that partition gets too high or your request rate gets too high. So that's kind of how DynamoDB achieves its, quote, infinite scale, unquote, just by adding or splitting partitions up. So moving on to access now. Access is pretty straightforward for Dynamo. You use the AWS SDK. Depending on what language you're using, I know the popular one for Python is Bodo Core. There's one for all you Node.js developers as well. But there's very different language-specific kind of flavors that essentially offer the same functionality at the end of the day. If you're not happy with using that, there are some language-specific ORMs or object relational mappers that exist out there. I use Java a lot. The one that I'm very familiar with is DynamoDB Mapper, which is an excellent way to abstract some of the complexity when trying to talk to DynamoDB. It gives you kind of an interface to perform a lot of the very typical operations such as queries, scans, and pagination, things like that. All right, so we covered structure, storage, scale, and access for DynamoDB now. Now let's kind of wire this back to the comparison between RDS Aurora and DynamoDB, because it does require a very different mental model, a very different way of approaching the problem. And I think this is where a lot of people get lost when they try to compare one or the other, because it requires a very different perspective. And I figured the best way to describe this is through just an example. Let's just give a very practical example using either RDS Aurora compared with DynamoDB. So let's start with RDS Aurora, and the mental model that you use when you're using Aurora and basically any other SQL database is that you start with your data relationships. So you say to yourself, what is the problem set that I'm working with? What are the relationships between our data? Let's define a schema that respects that relationship. And then you would go and build out your tables that kind of respect that schema. And then you would, after the fact, start accessing your data in a way which is compliant with those relationships that you defined. Now, DynamoDB is very much so different. You don't start with your data relationships. You start with something different. You start with your access patterns. So you ask yourself, not how is my data structured, but how do I want to access my data? How do I actually want to retrieve it? Is it by specific keys? Is it by specific ranges between dates? What are you trying to do? How are you trying to access your data? So as you can imagine, these are very different mental models when you are comparing these two things, and you need to structure your data in a way that is fitting for each of these two different solutions. So let's take a practical example using a customers and orders example, where we have a set of customers that place orders maybe on an online marketplace or something. So let's start at the top with Aurora. So I have orders that come in, and this is a very kind of typical orders table where you have your primary key being your order ID, you have your customer ID, which is a foreign key which points to another table, which is your customers table, and then you also have date there, which corresponds to when the order was placed. So because you're working with a SQL engine here, you would probably define your foreign key to link up to the primary key of your customers table, so that you can very easily answer questions like what are all the orders for customer ID 1, which happens to correspond to John Doe. So this is a very traditional way of setting up your RDS Aurora. You would define these relationships, and now how you access your data is dependent on those relationships you define and the schema that you define. Now, how does this work? How would we solve this exact same problem with DynamoDB? So you would start with a very different process. You would start with a statement such as, I want to be able to access my data by blah. And whatever blah is, that would influence how your DynamoDB table structure exists. So let's take a practical example. Let's say that I want to be able to access all order IDs for a customer by their customer ID. Okay, so I want to be given a customer ID that is going to be provided to me, and I want to know all order IDs that are associated with it and all the details about that customer as well. So how can we do that in DynamoDB? So let's take a look at this table here, which is one that I quickly put together that works for this access pattern that we've defined ourselves. So what we do here is we have our customer ID, and this is our partition key. And then we also have a sort key, sometimes also called a range key, that exists, and that's going to be our order ID. So what you can see here is the combination between these two things, 1 and 997, 1 and 998, 2 and 999. These are unique combinations. So as a conjunction, these two things formulate our primary key. And then from there, we have customer details that correspond to kind of what we had over here for our customer table. Instead, now we are just storing some raw JSON to denote the customer details of our independent customers. Now, if you're glancing at this, a very obvious question is, hey, Daniel, what's going on here? You are repeating your customer details for more than one row here. That's not good. You have data duplication. And you would be exactly right. And this is part of the pros and cons balancing act between using RDS and DynamoDB. You are able to achieve very high throughput for this particular access pattern that we've defined, but the penalty that you have to pay to play this game is that you suffer from some form of data duplication. Now, this isn't necessarily a terrible thing, right? Like DynamoDB is extremely efficient. It can store a whole ton of data very simply. So is this really a problem? I would argue not, because you're being cognizant of the limitations here, right? You are saying to yourself, I am willing to suffer some form of duplication in favor of better throughput and better performance overall. So that's the price of the ticket and what you pay in exchange for that performance upgrade. Now you may ask yourself, well, doesn't this cause problems? Like what if, the customer details change for John Doe? What if he wants to change his address at some point after he places an order? And you would be exactly right. Again, part of the consequences of using DynamoDB in this case is that now if a customer places an order and they want to change their address, you need to do something like take a look at this table, find all the order IDs for this customer that are still open, and then go and modify all of the addresses that are corresponding to open orders for that customer. Whereas if we just had a customers table up here and an orders table here, we would just change the address for John Doe, and then you'd be off to the races. Everything just works. So all the open orders would be mapped to the new address. So this is an example, like a very practical example of how you would model your data using something like RDS Aurora compared with something like DynamoDB. So hopefully this gave you a sense of what kind of problems you'll be dealing with if you're working with one over the other. One final point here is don't try to design a DynamoDB table as you would a RDS table. It's just not going to work, and this is the trap that people fall into and they end up giving up and say, oh, I hate DynamoDB, let's go back to RDS. You need to think about how you want to access your data. Can't stress that enough. A lot of the time that you need to spend is upfront to understand, hey, how do I want to actually access this? How will my potential use cases evolve so that in the future I can very easily just add an index to something so that, if there's a new use case, I can access that data easily. That's something you need to think of ahead of time when you're working with DynamoDB. Whereas when you're using something like Aurora, it's more of like, this is my data, now go and access it. So that kind of gives you an outline of what the difference between these two technologies look like. Let's move on now to talk about like when to use what. How do you actually decide from a practical perspective? So first I want to work on the left side here, which is Amazon Aurora. So you want to use Amazon Aurora when you want to keep the door open for flexible access patterns. So as we saw in that previous example, you define your schema, you define your structure based on your data, and you define those relationships between your data. This makes it very easy to pivot in the future. If someone comes along and says, I want to select my data in this way, it's very, very easy to do that. If someone comes along and wants to add another table for a new relationship, very, very easy to do that. When it comes to Dynamo, not so easy to do that. So if you have a use case where maybe you're just prototyping something, or you're not really sure how your application is going to evolve, you want to use something like Aurora that's flexible in nature, that's going to be able to allow you to query by all sorts of different access patterns. Secondly, when you want to perform bulky relational style queries, things like grouping, things like aggregations, things like very sophisticated filtering, this is a better choice for Aurora. In fact, DynamoDB does not even offer any form of grouping or aggregations or group by clauses or anything like that. If you want to do that in DynamoDB, you would need to pull all the data out by value or by key rather, and then do some kind of grouping on the application tier. Whereas when you're using something like Aurora, you can offload a lot of that complexity to the database instance so that you have a lighter load on your application layer. So Aurora is great for performing these types of queries, and especially with the addition of read replicas, you can always add more read replicas to help you deal with the demand of these large style grouping and aggregation style queries that are usually more computationally expensive. Now, thirdly, when you want to enforce schema constraints, this is something that I think a lot of people gloss over, but when you're using an RDS and Aurora in particular, you are able to define schema constraints that enforce at the database level that certain fields and certain columns are always of a specific type and look the same. In Dynamo, that is not the case. You do not have a fixed schema, you have a flexible schema. So that's something to be very, very aware of. If that's something that you care about, then you're going to want to use Aurora. And if it's something you don't care about, then DynamoDB is good for you. And finally, from the kind of support perspective, when you want to use a ubiquitous access language such as SQL. SQL is everywhere. Everyone knows SQL. If you don't know SQL, you probably should, because at some point in your life, you're going to need to run some kind of queries against a database. And there's a whole bunch of support that exists for SQL queries and performing different groupings and all that kind of stuff. So that's the extra value add that you get by using Aurora, by having a whole ton of support that exists out in the wild that will be able to support you with any questions in terms of SQL itself. So shifting gears now to DynamoDB, when do you want to use that? Well, when you have predictable access patterns, when you know in advance, I'm going to access my data in this particular way or these particular sets of ways, and you want to achieve high performance on that. When you know in advance, it's a good idea to use Dynamo. And when you're convinced that that's probably not going to change, definitely a good idea to use Dynamo, because you're going to be able to scale a lot further if you use something like Aurora. And secondly, when your search key is known in advance, this is something that some people don't think about actually. So when you're using Dynamo, there's no such queries that you can do, such as give me all the rows with a creation date between these two ranges, these two dates. You can't do that with Dynamo. You need to know the key that you are looking for in advance. So instead, you would have to do things like give me all the values that have this key and are within this particular date range. This may not work for some of you, for some of your different use cases. So keep that in mind. That's a limitation. And when you're using Dynamo, you need to know what key you are looking for. Whereas when you're using something like Aurora, you can do that fuzzy logic, that fuzzy search criteria that is like, give me all the stuff with this elaborate list of criteria. Dynamo is much more rigid in this sense. You need to provide it with your keys in advance. And thirdly, when you are willing to sacrifice flexibility for ultra fast and consistent performance. This is really the big selling point at the end of the day. Consistent performance that's ultra fast is what you get with DynamoDB, provided you don't do something crazy or faux pas from the table design perspective. But when you're using Dynamo, you kind of limit yourself to a particular fixed set of access patterns, which you typically define in advance. However, you can basically rest assured that your application is going to scale essentially infinitely. So that's the kind of trade-off that you get between one and the other. You get excellent speed, consistent performance, and essentially infinite scale at the cost of flexibility. So that's all I got for you today. If you enjoyed this video, I have a whole bunch more on Aurora and DynamoDB. I'll put playlists up on the pop-ups here. And as always, if you enjoyed the video, please don't forget to like and subscribe, and I'll see you next time.